Hey everyone, we're going to take a look at number 2 in section 10.5. And before we do, I just want to remind you that you'll have this sheet which gives all the different tests as well as, of course, the ratio test, which this problem asks us to use. And so for this series, the first column here is conditions for convergence, second column for conditions for divergence. We look at the limit as n goes to infinity, the absolute value here of basically the ratio of successive terms in this series that we're adding up. And if that limit is less than 1, the series is absolutely convergent. If that limit is greater than 1, the series diverges. Of course, if that limit is 1, this test is inconclusive. And all they want in this particular problem is to state one of these three outcomes just using the ratio test. So let's take a look at the problem. We want to apply the ratio test to this. And so I'm going to take a look at the limit as n goes to infinity, a sub n plus 1 to a sub n. So this right here is the a sub n plus 1. And this over here is the 1 divided by a sub n, right? So, just instead of dividing, I multiply by the reciprocal here. And so all I'm doing here is replacing n with n plus 1, and then here I'm doing the reciprocal. Okay, so we can do some simplifying. Remember, 6 to the n plus 1, that is the same thing as 6 to the n times 6, right? We would add the exponents. And so this 6 to the n and this 6 to the n, we can divide numerator and denominator by that, and we simplify. Of course, the absolute value bars really kind of go away because for n going to infinity, these expressions will be, of course, positive. Well, they're positive anyways to the 90th power. And so we can now get rid of that and simplify. So up top, I'll get 6 times n to the 90th power. And then in the bottom, n plus 1 to the 90th power times 1. So this is what I have. Take the limit as n goes to infinity. And again, the problem you have might have slightly different numbers here, probably a very high exponent. And you might be like, wow, what in the world's going on here? How are we going to handle that? Such a high power on n. Well, notice this. The 6 is just a constant multiple. And so I'll pull that outside. And what am I left with? N to the 90th over n plus 1 to the 90th. Well, anytime I have a to the n over b to the n, I can rewrite that, right, as a over b all to the n power. And that's basically what I'm going to do. And now I can take the limit inside this function because it is continuous, right? And then the limit as n goes to infinity of this, I hope everyone knows, is 1, right? And you can use L'Hopital's rule one time to determine that if you need to, but 1 to the 90th power is 1, and so this limit becomes 6. Since 6 is greater than 1, as we talked about a minute ago, we know this series diverges by the ratio test. So even though we have a very high power on n, look at n to the 90th power, that grows very rapidly. 2 to the 90th power is huge versus 6 squared, which is just 36. But the exponential function eventually will dominate this algebraic function so much that these terms will begin to blow up and get bigger and bigger for very large n, and this series will clearly diverge. And we're just showing that with the ratio test. Okay, hope this is helpful.